Welcome back to our system design series. Today we are diving into a concept of heartbeats in distributed systems. Heartbeats are a fundamental mechanism for ensuring that the health and stability of distributed environments are well, so where multiple components must work together in harmony. So, what is exactly a heartbeat? So, let's just imagine that we have two components. We have like a client and we have a server, okay? And we need to know what's going on between both of them. So, in the distributed systems, a heartbeat is just a periodic message sent from one component to another to monitor each other's health and status. It's act as like simple, like like hey, are you alive? If this is what is the point of it, like allowing different parts of the system to know that their peers are functioning correctly. If a component stops receiving heartbeats from another, it can infer that the peer might be down or unreachable, promoting that the system promoting like the system to take like appropriate action against that. So it will be like, as we said, it's will be something like over a period amount of time. So let's just make it like this. Uh-huh. And I want to make it thick. And let's copy it and put it here. No, no, no. Okay. And yeah. Why? Mm-hmm. And yeah. Okay. This I guess this is good. So it will be something like that. Like let's assume that the client will send a heartbeat to the server over every like 5 seconds, for example. And this heartbeat, it will indicate to the server that the client is online. And it will try to send heartbeats, but when it doesn't send any heartbeats anymore for a specific amount of time, it will be known as offline. Okay, let's talk about this in details about how it works. So, heartbeats are typically implemented using periodic messages sent at regular intervals from one node or a service to another. First, we have sending heartbeats. Like each node or service sends a heartbeat message at a periodic, a predefined interval. This message is a simple signal that indicates the node is functioning properly, like a proper way, in a proper manner. The second thing, we have receiving and monitoring. Like the receiving, which here is the server, the receiving component keeps track of the incoming heartbeats messages. If it receives the heartbeat within the expected interval, everything is assumed to be functioning normally. And the third thing, we have the failure detection. Like if the component stops receiving heartbeat from a peer for a certain period, it marks the peer as unhealthy or failed and trigger appropriate recovery actions, such as failing over mechanisms to back up node or alerting an administrator. So let's just try to understand why this is important. I guess you might understand why this is important, but let's just talk in details. So, what you will say in your system design interview. So, in distributed systems, a heartbeat play a crucial role in distributed systems for several reasons. Without a proper heartbeat mechanisms, it becomes challenging to detect failure prominently, which lead to, like, for example, we might have a in delayed fault detection. Let's put D for detection. and recovery. So when components in distributed systems fail, it's important to detect these failures as quickly as possible to initiate recovery measures. Without heartbeats, it may take much longer to identify that a component has failed, delaying the recovery process. Number two, we have increased downtime and error. Increased uh, downtime and error. So delayed detection of failures leads to increased downtime. The longer a failure goes unnoticed, the more potential errors are and disruptions occur, which can severely impact the user experience. And number two, we have decreased overall system reliability. Decrease is like decreased overall the system reliability SR. So a key goal of distributed system is to ensure high availability and reliability. Without a heartbeat mechanism, the system cannot reliably determine the status of its component, reducing its ability to provide a consistent and stable service. So this is why we needed. We can make an example of a real world example. I guess you can just like imagine a distributed database like Cassandra or MongoDB that has multiple nodes replicating data. Each node periodically sends a heartbeat to its peer to confirm that it's alive and healthy. If a node fails to send the heartbeats within the expected frame time, the other nodes detect the failure and redistribute the workload to ensure data remains accessible. This automatic failure detection helps maintain the system high availability. There are some challenges in the heartbeat, like the network latency. Maybe we have some sort of scalability because as the number of nodes grows, managing heartbeats between every pair of nodes can become really tough and not that easy, to be honest. There's also like a threshold tuning because setting the right interval and the time threshold is crucial for that. We might make some videos to talk about the challenges that we can find in heartbeats. Um, but yeah, on high level, I guess this is what we need to talk about. And in context of system design interview, you don't need to know more than that. So yeah, that's it for this video. And in this video, we explored heartbeats in distributed systems, a crucial mechanism for maintaining system reliability and ensuring prompt failure detection and recovery. We discussed how heartbeats work, why they are important, and some of the challenges in implementing them effectively. Like heartbeats help ensure that all components in distributed systems are functioning correctly, allowing the system to quickly detect issues and take actions, thereby reducing downtime and increasing reliability. So that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss any video, and see you in future problems.